Here is a quick overview of what we will cover. We will cover the laws of thermodynamics and value theory, Smith's thermodynamic mistake, the greatest hits of classical economics, economics from first principles and data, insights from the laws of thermodynamics, application, a real-world walkthrough, summary, how the lecture fits together. We will start with the foundations, build step by step, and end by tying the ideas together. The relationship between energy and value in economics is crucial. How we use natural resources to create wealth. Put more directly, value theory examines how value is created and distributed in an economy, influenced by energy inputs and societal structures. For example, consider solar energy as a free resource. When we harness it to grow crops, we are using a natural gift to create food, which has value. What this example shows is that the value of food is not just from labor, but also from the energy provided by the sun. Understanding this relationship helps clarify how wealth is generated and challenges traditional economic theories that overlook energy's role. Once that is clear, the next step is Smith's thermodynamic mistake, because it develops the next piece of the same argument. Adam Smith believed labor was the main source of value, but he overlooked the role of energy in manufacturing. Put more directly, Smith's thermodynamic mistake refers to his failure to recognize that energy, particularly from natural resources, is crucial for production. For example, in the Industrial Revolution, coal was used to power machines, representing stored solar energy from millions of years ago. What this example shows is that the increase in production and wealth during this period was largely due to the use of energy, not just labor. Acknowledging this mistake helps us understand the ongoing debates about the sources of economic value and profit. Once that is clear, the next step is the greatest hits of classical economics, because it develops the next piece of the same argument. Classical economists like Smith, Ricardo, and Marx made important observations about society and value, which still resonate today. Put more directly, the greatest hits of classical economics refer to the significant insights provided by early economists regarding social classes and value creation. For example, Ricardo argued that the cost of production, not supply and demand, ultimately determines the price of goods. What this example shows is that understanding production costs is essential for analyzing market prices, rather than just looking at supply and demand dynamics. These insights challenge modern economic theories and remind us of the importance of production in value creation. Once that is clear, the next step is economics from first principles and data, because it develops the next piece of the same argument. Using data helps us understand the relationship between energy consumption and economic growth. Put more directly, economics from first principles and data emphasizes the importance of empirical evidence in understanding economic phenomena. For example, global GDP data shows a strong correlation between energy usage and economic growth. What this example shows is that this indicates that as energy consumption increases, so does economic output, reinforcing the idea that energy is a key driver of wealth. Analyzing data allows economists to make informed decisions and understand the real drivers of economic performance. Once that is clear, the next step is insights from the laws of thermodynamics, because it develops the next piece of the same argument. The energy consumed by machines has dramatically increased since the Industrial Revolution, impacting living standards. Put more directly, insights from the laws of thermodynamics focus on the relationship between energy consumption and economic development. For example, the James Watt steam engine consumed 12.5 pounds of coal per horsepower per hour, while modern rockets like SpaceX's Falcon 9 consume energy at an exponential rate. What this example shows is that this illustrates how advancements in energy consumption have led to significant increases in productivity and living standards over time. Understanding these insights helps us appreciate the role of energy in economic growth and the limits of efficiency. Once that is clear, we can pull the whole lecture together and see the full logic in one connected chain. Consider a simple hypothetical market facing a shock. A basic textbook model would usually isolate one variable and ask how the system returns to equilibrium. This lecture takes a different approach. It asks what happens when several forces move together, feedback on one another, and change the behavior of firms, households, or institutions over time. That is why the concepts in this lesson matter as a group. The application slide is where the theory becomes usable. It shows how the lecture helps explain a system that evolves instead of sitting still. This lecture builds in 3 moves. First, The laws of thermodynamics and value theory, Smith's thermodynamic mistake, define the problem and show why simple equilibrium thinking misses too much. Then, the greatest hits of classical economics explains the mechanism that actually drives change in the system. Finally, economics from first principles and data and insights from the laws of thermodynamics apply that logic to real competition and industry behavior. The full lesson is that once multiple variables interact, innovation matters and firms respond dynamically. Economics has to explain process and feedback rather than assume the system settles down by itself.